Welcome to vBrownBag. I'm Michael Webster from Nutanix. I'm one of the Senior Solutions and Performance Engineers for the Global R&D team, and I'm here to talk to you today about virtualizing enterprise applications on web-scale architecture. But I thought I'd do it slightly differently than just a slide deck. I thought I'd actually show you how it works. And I not only wrote the book about SQL Server, but I do a lot of work with Oracle, Exchange, SAP, and a lot of other workloads. And I'm one of the VMware certified design experts that work at Nutanix. So what we've got today is we've got Oracle Rack 12c with 3 nodes, monster virtual machines, and we've got that set up in a test environment. And this is the test environment here. So we've got one Nutanix appliance with 4 nodes in it. We've got the test harnesses running on one node, and then we've got the Oracle Rack virtual machines running on the other 3 nodes. We're using Oracle Rack 12c with single client access name to load balance all the connections. And then once it's under 100% load, that's not just good enough for me. I want to vMotion all of those virtual machines at exactly the same time to put it under a maximum amount of stress. So here we go. This is the Nutanix user interface, which is an HTML5 interface, which makes it very, very simple. And at the moment, you can see we're doing about 10,000 IOPS at about 5 milliseconds of latency. This is across all of those 3 Oracle Rack nodes, and it's just in 2U of space in the data center. Now we've also got compression enabled, and we're saving about 30% of our space using compression in this particular environment. Now I've written a script that goes through, and what it's going to do, it's going to vMotion each of those Oracle Rack nodes at exactly the same time while all the client sessions and everything is still connected, while it's still under load. Now why is this important? It's important because we're using the same network for the storage traffic, we're using the same network for the Oracle cluster interconnect, we're using the same network for vMotion, and we're also using the same network for all of the client session traffic as well. So if there was any blip in the network, we could get Oracle Rack nodes getting evicted, we can get client sessions disconnecting, and things like that. So this is going to show you the process of what happens when we actually run through and do this vMotion. So right now the network's under about 200 megabytes per second of throughput, and this is the test harness that I'm using, Benchmark Factory for databases, and it's a TPCC type workload, so it's 50% read, 100% random sort of transactions, inserts, updates, selects, and that sort of thing. So what we're going to show you now is the CPU usage. So CPU usage, you can see, is at 100% essentially throughout this test, so I'm putting it under a very high extreme amount of load. So this is like a worst case scenario test. You wouldn't normally do this in production. Now if we look at the memory, so each of the Oracle Rack nodes has got 112 gigs of memory and 8 CPUs, and you see about 50 gigs of that memory is active at the moment. They're all configured with an 80 gig SGA. Now power consumption, even though this is under 100% CPU load, each of the nodes is only using 200 watts of power. So across the 4 nodes, we're only consuming 800 watts of power for this entire test. Right, so now we're back to the network and we're about to kick off the vMotions. So this part of the test is actually in real time. I haven't sped it up. So it takes about 2 minutes from start to finish to migrate all 3 of these monster Oracle Rack virtual machines. And you can see the test harness here, we're in a steady state. Now what we will see shortly is a slight blip in the network traffic and also a slight blip in the response times. Now that's normal as we're saturating the network with over 30 gigabits per second of network traffic. So here we go, we've got all 3 Oracle Rack nodes now in motion at the same time, going across all of the same 10 gigabit network. And you can see we've had a slight spike at the start of this test in terms of response times for the users. But you can see that our average transaction rate is still around the same. So we're still doing about 550 transactions per second. So we're still in the steady state. The vMotion traffic is still going through. And we'll flip back to vCenter, and we can see now that we're doing 30 gigabits per second of throughput in the vCenter, and that's all of the traffic going across there. vMotion, Oracle Rack Interconnect, the storage traffic, and the user traffic as well. About halfway through the migration, so we're about a minute into it, and it's going to take 2 minutes in total to migrate all 3 of these virtual machines. Now if the virtual machines were configured with more memory, then that would take longer to migrate as well. But we're still getting very, very good throughput on the network at the time that this is happening. And we've still also got very good throughput in terms of IOPS on the system as well, and latency. And we'll flick back to that in a second and show you exactly what the latency is for these systems. So we've got one migration's completed. The other ones are just about complete. There we go. So all three are now completed. Those migrations in just on 2 minutes from start to finish. Now, if we quickly go back to our test client, and we're going to see there was some slight degradation for some of those user sessions during the migration. And what you'll see is this, this happens for a very short moment in time, and then it will go back to a steady state. But more importantly is the errors or disconnections of any user sessions. And what you can see where the mouse is pointing at the moment is there was absolutely no disconnects, no errors as this test was going through. So even though it's under an extreme load, the users weren't actually disrupted apart from a momentary reduction in performance, which happens with every vMotion operation. You wouldn't normally be vMotioning your Oracle RAC servers under 100% load during the middle of the business day. Most Oracle RAC environments are designed to run at about 50% to 60% utilization. But you can see after the vMotion operation, it all went back to a steady state. Now, we also did have a brief blip in IOPS during this test, even though the latency stayed consistent, and that's just as those virtual machines were transitioning from one VMware host to another VMware host. This test was done using ESXi 5.5, update 1 with the patches for NFS, so patch 4. Now what we're also going to do is we're going to migrate all those virtual machines back to where they came from. So not only is this demonstrating Oracle RAC nodes under extreme load and the entire architecture under extreme load, it's also going to demonstrate what happens when the virtual machines move and their data is on different disks or a different node in the Nutanix architecture. Because with Nutanix, on every single node there is a storage controller, and that storage controller is responsible for all of the storage I/O. So you can see now that we are migrating back again, so we've got all three Oracle RAC Monster VMs in motion at the same time. Now I have sped this up, so this isn't real time. It did take the same approximate 2 minutes to do the migration back again. But this shows you what you can do with Oracle RAC, even for maintenance of physical hardware underneath. So the advantage of virtualizing Oracle RAC is that your nodes, if there is a failure, they come back almost instantaneously within a few minutes. So you don't have to wait for the 4 hours for the hardware to be replaced. But it also means you can do completely non-disruptive hardware maintenance of your environment without impacting your user community. So here we are again, back after the migrations are completed, and we're completely back to the steady state again, and we're still doing about 500 transactions per second across these Oracle RAC systems. What's more important is there hasn't been a single user session disconnected, and there hasn't really been any interruption whatsoever to these Oracle RAC databases, even though there are under 100% CPU load, as we can see here. Thanks. So this is one of the Oracle RAC nodes, and you can see the CPU there is at 100% usage. This is after the migrations are completed. And the network, we're doing about 20 megabytes per second on the network. That's just in the Oracle RAC interconnect and the client traffic. And if we skip back again to our test harness, what we're doing here is still doing around about 5 milliseconds in latency. So throughout this entire test, we're still doing thousands of IOPS and very low latency for this entire operation. And it's as easy as that. Nutanix makes the architecture underneath the applications invisible, and you just get to design your virtual machines the way that you would in any case, without having to manage the complexity, without any LUNs, without any multipathing, without any zoning, and without any issues with regards to high performance applications, even in a web scale architecture. Thank you very much.